lesson using intercepts. And there are two types of intercepts that we'll be talking about. There is the y-intercept and the x-intercept. And two very simple concepts. Basically what an intercept means is the point in which a graph will cross that specific line. So for instance, the y-intercept is where a graph will cross the y-axis, and the x-intercept is where a graph will cross the x-axis. So I can actually jump to A right away here and look at, if I wanted to find the x and y-intercepts, here's the x-intercept at -4, 0. So this is the x-intercept right here. Alright? And you'll notice in the definition that for the x-intercept, that is when the y-coordinate of that point is 0. Okay? Same for, or vice versa for the y-intercept. This is where my graph crosses the y-intercept, so, or the y-axis, sorry. So my y-intercept is going to be 0, -3. So there's my y-intercept. So the y-intercept happens when x is 0, okay? So that's how, they're very simple to find on a graph. But let's say we look at letter B and they tell us, okay, let's find the x and y-intercepts of this equation. You have some options. You can graph it and figure it out that way, but there is a very simple fix to this. Oops, sorry. Remember the definition says the y-intercept is when x equals 0, and the x-intercept is going to be when y equals 0. So let's just plug 0 in for both and see what we get. So here's what I like to do. If I know that x is 0, 3 times 0 is gone. So this is no longer there. And we're just left with -2y equals 12. Well, if I divide both sides by -2, I'll solve for y, which is -6. So here's my y-intercept. That is where this graph will cross the y-axis at 0, -6. And then we can do the same thing for the x-intercept. If y is 0, now this is gone. And now I have 3x equals 12, or 3 times x equals 12, so x must be 4. So here is my x-intercept. And more specifically, sometimes you'll see it written as the y-intercept equals -6, the x-intercept equals 4, but you can put it in point form here. So 0, -6, and 4, 0 is where this graph is going to cross those two axes, okay? And you can graph that and find out that that's true. So sometimes they'll ask us to use intercepts to graph an equation. And if you're ever using intercepts, it's easiest to have the equation in standard form. So a quick review on that: if you've got fractions, remember you want to get rid of those. So I'm going to multiply through by 6, since 3 and 2 have a common multiple of 6. Alright, so now we've got divide by 3. So 2 times 2, 4y equals 4 times 6, which is 24, and then minus, divide everything by 2 here, minus 3x. And then to put it into standard form, I'm going to add 3x to both sides. And we're left with 24 equals 3x plus 4y. Okay? And if we know it's going to be linear, and it should be because it's in standard form, so it'll be a straight line, all we got to do is find our intercepts to graph. If it's a straight line, we only need 2 points. So if x is 0, this is gone, and I'm left with 4y equals 24. Well, y has to be 6. So 0, 6. 1, 2, 3, 4, 5, 6. So that's my y-intercept. If, get rid of that now. Well, here we go. If this is now gone, if y is 0, what's x going to be? Well, that's going to have to be 8, since 3 times 8 is 24. So over 8 up 0, 1, 2, 3, 4, 5, 6, 7, 8. Here are my x and y intercepts. If I just connect those, I've got my line. And we know it's going to be a straight line since it fits in standard form. how we use intercepts to graph. Alright, so that's all I've got for you today.